Hi there, welcome back to the channel. This is Thiru, the author of Bitbee. Today we're diving into the fourth problem from our Leetcode 150 list, product of array except self. It's a medium level problem from the arrays data structure category. As part of this Leetcode 150 problem series, we've already solved 3 problems: to sum, best time to buy and sell stock, and remove duplicates from a sorted array. You can find the link to the full playlist in the info section or the video description. It covers all the problems with solutions ranging from naive to optimized approaches. Now let's dive into our fourth problem. Before we jump into the solution, make sure to subscribe to the channel and hit the bell icon so you don't miss out on our visualized coding problem solutions and interview questions. So we have given an integer array numbers and we have to return an array such that in resultant array ith value is equal to the product of all the elements of numbers except ith value from input array. To understand the problem statement better, let's look at an example. In example 1, the given array has 4 numbers 1, 2, 3 and 4. The resulting array is calculated as follows. At index 0, the product of 2 cross 3 cross 4 gives 24. At index 1, the product of 1 cross 3 cross 4 gives 12 and so on. Similarly, in example 2, the input array contains some numbers and the value at index 2 is 0. As a result, in the output array, the product becomes 0 for all indices except for the second index. I hope the problem statement is clear now. Let's start by thinking through a naive approach and then we'll gradually optimize our solution to achieve a time complexity of O(n). I'm taking a sample input array with 6 elements, that is 10, 4, 1, 2, 5 and 3. So as a brute force or naive approach, we can calculate the product array using 2 loops. The outer loop iterates over each element in the array, and then using inner loop, it calculates the product of all elements except the current one by multiplying all the other elements. This is very straightforward approach, but of course, due to nested loops, it will have the O of n squared time complexity. You can just go through the visualization of this solution for your understanding. Initially, we'll have 2 pointer variables, both starting at 0, which will serve as the starting points for our outer and inner loops. We'll also have a product variable where we'll keep updating the calculated product for each element through the iterations. So when the first iteration starts, the calculation for the 0th index product will begin. The result will be 4 cross 1 cross 2 cross 5 cross 3, which is equals to 120. Similarly, for the second iteration, the result will be 10 cross 1 cross 2 cross 5 cross 3, which is equals to 300. And remember an important detail here. At the start of each iteration, we need to reset the product variable to 1. This ensures that for each element, the product calculation starts fresh, right? The same way, products will be calculated for the entire array at the end of the 2 loops. As mentioned, this solution has a time complexity of O(n) squared. For space complexity, other than the resultant array, we are using 3 variables, the 2 pointers and the product variable. So the space complexity is O of 1, which is constant, right? Now let's code this brute force solution in both Java and Python. Starting with Python, I'll define the method that takes the input array as an argument, and then we declare the resultant array, which will have the same size as the input array to store the result. Next, we start the 2 loops inside the outer loop. Before the inner loop begins, we set the product variable to 1. Then we calculate the product for each element through the iterations as explained. At the end of the method, we return the resultant array as the solution. This is as simple as that, right? When I tried to execute this Python solution in Leetcode, it is working, but it's failing for acceptance with time limit exceeded. Since this solution only works for smaller arrays, hence we need to optimize this solution further, right? Now let's try to write the same code in Java and we'll execute it again on Leetcode. I hope if you are a Java B, you are able to follow this solution. Let's execute this. There we go. Still it's failing with time limit, right? To optimize our solution from O(n) squared time complexity, we need to avoid the nested loops. The idea is to use 2 loops independently without nesting them. So in the first loop, we will calculate the product of all elements to the left of the current element, which we'll call the prefix product. Similarly, in the second loop, we will calculate the product of all elements to the right of the current element, which we'll call the suffix product. During the iterations, we will store the prefix and suffix products separately in two different arrays. Once all the prefix and suffix products are calculated, we will multiply the prefix and suffix values at the same index, which will give us the final result. So as shown in the visualization, we are calculating the prefix products for each element and filling the prefix array. For the 0th element, the prefix product will be 1 since there are no elements to the left of it. For the first element, the prefix product will be 1 multiplied with 10 equals 10. For the second element, the prefix product will be 10 multiplied with 4 equals 40. For the third element, the prefix product will be 40 multiplied with 1 equals 40. Similarly, we will calculate the prefix products for all elements. Then in the same manner from end of the array, suffix products will get calculated using separate loop. And at last, we'll fill our resultant product array by multiplying the prefix and suffixes at the same index, right? So we have achieved the final result without nested loops. Even though we are using 3 loops, they are independent of each other. So overall time complexity will be O of n. Also, we are using 2 extra auxiliary arrays of size n to store prefix and suffix products, right? So our space complexity will become O of n. Now let's code this solution in Python. Solution is simple again. We'll declare 2 auxiliary arrays, prefix and suffix, along with resultant array of size n each. Then with 2 different loops, we'll calculate prefix and suffixes of each element. And using the third loop, we'll fill the resultant array and return it as our solution, right? So when I tried this Python solution in Leetcode, yep, it's got accepted and we don't see any time limit exceeding error now. We have to consider one thing here, that is still we can improve the memory or space complexity part here. Now let's write the same code in Java. So there is no change in logic, just the Java syntax change. And please do not worry about the code. I have already provided the GitHub link for all the solutions in this video description. Yeah, now let's execute this Java code. Yes, this also got passed. That's good, at least than our naive solution, right? So we have seen still some improvement requires in space complexity, right? As a third or optimal approach, what we can do is at first, we will avoid using auxiliary arrays. In first pass or in first loop, we'll use only the resultant array to store the prefix products. For example, result of I will contain product of all elements to the left of I, as we did in previous approach. Finally, in our second pass or second loop from n to begin, we will use a single variable to calculate and store the suffix value, and then immediately we'll calculate the product with prefix value already present at the respective index. In this way, we can fill the result from right to left index, right? If you did not understand, no worries. Let's try to visualize this by taking same input array. We'll simply iterate through the input array in first day pass and we'll fill the resultant array with prefix products. We already know what is prefix product for each element and how to calculate it. So we are doing the same thing here in first pass. Now in the second pass, beginning from the end, we'll just multiplying our prefix values with its right value or suffix, which is giving us the final result. Clear, right? So this is how we optimize the space complexity just by avoiding the auxiliary arrays and on-fly prefix suffix multiplication in final pass or loop. So if you see here, we have got the same resultant array what we have achieved in our 2 previous approaches, right? And we drastically brought down the space complexity also from O of n to O of 1. Now let's try to code this and execute on Leetcode environment. Let's start with Python code for this approach. I am just taking only the resultant array to return it and no more auxiliary arrays such as prefix or suffix. Then as a step 1, starting the first loop and under the loop for each element calculating the prefix product and placing the values in our resultant array. And in final and important step, starting the second loop where I will use suffix to store the product of prefix value and current right suffix, right? End of the loop, we'll have all the values filled with our desired products. That's it. So when I try to run this optimal solution in Leetcode environment, yep, here are the results. It's got accepted with 98%, which is looking very good, right? Yep, now let's also try the same logic with Java code. So for Java Bees, I am just implementing the same optimal logic with Java syntax. You can follow the code here and later in GitHub link, no worries. So the results for the Java code in Leetcode are bang. Wow, it's almost reached at 100%. That's great. So that is all about this problem and naive to optimal solutions. If you have any queries still, please mention in the comments. We'll definitely try to clarify them. So let's summarize this problem and different approaches we followed to reach the optimal solution for this. First, we approached this with two nested loops as naive or brute force solution, which is taking O of n square time complexity. Then we separated the nested loops and worked with auxiliary arrays for prefix and suffix products. That has O of n time complexity, but we end up with O of n space complexity, which is not recommended for larger arrays, right? So as an optimal approach, we avoid using those auxiliary arrays and we calculated products on fly and stored in the resultant array itself, which got optimized in terms of space complexity as O of 1, right? So please kindly share this series or channel with your friends, which can be helpful to master these and Leetcode with our visualized solutions. Thanks for watching and we'll see you in our next video.